Okay, logic gate time. I've already got them all laid out. I haven't connected all the wires, but we have switches on the left, the gates in the middle, and the lights they're going to turn on the right. I have a spreadsheet on the right that's going to put the different inputs in, 0 or 1, and tell all the outputs. So I'm going to start with a NOT gate. I had one extra switch there, but connect up the wire, and you notice the switch is off, but the light is on. It's not. It does the opposite. So if I turn the switch on, it turns the light off. So if input a 0 gives out a 1, input a 1 gives out a 0. So 0 gives you a 1 gives you a 0. Simple. NOT gate. Next one's going to be the OR gate, which is this one over here. I'm going to connect up the wires, and it's 0, 0, puts out 0. So I can put that over here, 0, 0, it gives out 0. Turn on one switch, input 1, so I get a 1 for the output. Next one, turn on that one, so it's 0, 1, gives you back a 1. And if they're both on, I already showed that, it will give you a 1 back. So it's either input 1 is on or input 2 is on, but it's also both. They both can be on. The next one is AND. So if the OR gate was this one or that one, then the AND gate is probably this one and that one. And we'll connect them up and see what happens. So if they're both 0, I do get a 0 back. 0, 0, 0. If I flip one switch, so input 1 is 1, input 2 is 0, I do get a 0 back. So 1, 0 gives me back a 0. If I turn switch 2 on, switch 1 off, still off, because again, AND. But if I turn them both on, input 1 and input 2, then I get the light to turn on. We get a 1, we get a 1, we get a 1. Ones across the board. Next one is NAND. So think of it as like not and, anything but and, not and. So I already connected 1, and you already see it's turned on. I don't even need this other input to get 2, or to get it on, but I'm going to do it anyways. So we got 0, 0, and that will give us back a 1, because not this one and not that one. So pretty good so far. If I flip a switch on, it is this one, but it's not this one. It's not and. Neither of them is both on. So 1, 0 gives us back a 1. Flip the second one on, same thing happens. 0, 1 gives us back a 1. But if they're both on, it's not and. It's input 1 and input 2. That doesn't work. That's going to give you back the 0. It's not and. So if you do 1, 1, 0, that's what you're going to get. Next one we got is NOR. Not and, not or. So we'll see what happens. I'll connect input 1 up. Light's still off. Not this one or this one. But not or. Not this one or not this one. Light turns on. So we'll see 0, 0 gives us a 1. But not or. What's going to happen if I turn it on? It's off because it's not or. So I get 1, 0 gives us a 0. So then probably the same thing's going to happen with input 2. It's going to give us a 0. But if it's both, not or, it's not or because it's both of them. It's like an and. So it gives us 1, 1, 0. So an XOR or XOR, I don't know how to say that one. And it doesn't have an easy one to remember like NAND or NOR, not and. But we'll connect the first one up. Light doesn't turn on. Connect the second one up. Light still doesn't turn on. So we got 0, 0, 0. If I turn 1 on, I do get some light going on. We got an input 1, 0, and we get a 1 again. If I input just 2 on, we get very similar things back. But what happens if I do both? Because it's not an OR gate, it's not a not OR gate. Off. Weird, huh? So 1, 1, 0. So I like to think of it, it's has to be or. It can't be both, it can't be neither. It has to be both. So like exactly XOR, exactly or is maybe a terminology of how you could do it. And those are all the gates. Very fun gates, but we got one more bonus one. We're going to do a NAND plus a NAND and see what that does. So I've hooked up two NANDs down here. I'm going to give them the same input. Why not? Just for fun. But I am going to say input 1, input 2. I'm going to separate them out. So we're going to say input 1, input 2. When I flip the switch, it's going to turn both on. So we will do and see what happens. So we'll turn on switch 1, which is going to be input 1 and input 2. So we got a 1, and I didn't put in output, but that will give us back a 1. So then if I hit switch 2, you'd imagine the same thing. So we're going to get 0, 0, 1, 1. We get a 1 back. I didn't do the zeros across the board. Oh no. So we'll move these down, or we'll just mess with them some more. Won't let me? It won't let me do that. Okay, so we got our zeros across the board up top. So if we hit them both, it is on. So how it's going to work is 1, 2, 3, 4, and 5. So we got, they're NANDs, so it's not AND. So if it's not this and this, they'll both be off. But then it's NAND over here. So they're not AND, they're not both on, so that it turns on. And if you look at the OR gate, it kind of makes the OR gate. So it's, if it's one of them or the other, so this would be our input 1 over here, it gives a 1. Our input 2 over here gives a 1. And then both on, it gives this. So we were talking like NAND gates can make every other gate. Here's an example of NAND gates creating an OR gate, which is kind of neat. Okay.